Hello everyone. Let's spend some time exploring powerful utility scripting capabilities in JDK platform. Many experienced Java practitioners don't know that they can do very powerful utility scripting using this platform. It is true that since its beginning, the JVM was designed to be cross-platform and for running the general purpose applications. The aspect of utility scripting was not in its initial goals. But it is also true that the capability to write powerful small utility programs using the high-level object-oriented syntax of the Java platform has always been a desired feature in it. And in the industry, these interpreted languages are the de facto standard for utility scripting. This missing feature was added as part of Java Enhancement Proposal 330 in Release 11. Well, this JEP-330 is all about in-memory source code compilation, which means that instead of saving the compiled .class files within the disk, they are stored in memory, and a custom class loader loads these classes, which are then eventually executed and converted into machine code. So we have a runtime code interpretation directly from Java source code files as part of this enhancement. But taking that perception that Java has become an interpreted language after this JEP-330 will be wrong. It will be incorrect to say that, because as I mentioned, the code compilation and class file generation is still happening, but the way of program launching has slightly changed. And instead of loading the class files from some disk location or some class path, this custom class loader is delegating these in-memory compiled class files to the application class loader. The Java engineers can now perform day-to-day automation tasks in DevOps or IoT areas. More specifically, they can now write the utility programs like these, specific to their use cases and using their existing expertise and skill set. So looking into the big picture, we now have 4 Java program launch modes available. 3 of them are already available in pre-JDK11 releases. So this 4th new program launch option has a big difference with the previous 3 options. In these 3 existing program launch modes, compiled .class files are required to launch a program. So if you are launching a program directly out of a class file or from an executable jar file, the case is same. The jar is nothing but a special packaging of class files. So similar is the case with an executable module. So this 4th new program launch mode is special here. .class files are no more required to launch a program, and we can simply have single file source code programs. So what this single file source code program actually means? It means that in JDK11 release, this single command is equivalent to these 2 pre-JDK11 commands, which are compiling and launching the program respectively. So before moving any further towards our main topic of utility scripting, I want to make sure that you and me, we both are on the same page. Let's consider pre-JDK release 11 behavior. Consider a simple hello world Java file. This file simply prints a hello world message to the console. My current JDK version is 1.8. And if I try to directly use my Java launcher against this source code file, it will simply not work. And I need to compile it first. Now I have compiled class file, I can run it using my Java launcher. Now coming back to our JDK release 11, directly using my Java launcher against my hello world source code file will trigger in-memory code compilation, class file generation, and class loading, and program will launch directly out of that source code file. Let's see. It worked as expected, and we don't need an explicit compilation here. So for the purpose of quick and small POCs where you generally need to share the ideas with the others, you don't need any special packaging, and you can just share your source code file with the others and they can directly run it. So this ability to quickly launch single source code file programs is a very handy tool. So with this quick overview, we now have an understanding that how direct program launching works in case of normal Java source code files. Coming back to the topic, let's discuss the source keyword. Let's create a hello world text file and copy the source code from our hello world example into this text file. This text file now contains valid Java source code. Upon using Java Launcher with this source keyword and mentioning the Java release version 11 against this non-Java text file, Java Launcher will start executing our Java source code in this text file. So using this source keyword at command line, activate single file source code program launch mode. And instead of looking for a main executable class file, this Java launcher starts interpreting Java source code present in the given text file. The JDK release version here must be either 11 or higher. Using previous JDK releases here will result in error. Before showing you how you can use this single file source code program launch mode to do utility script programming in Java, I'll quickly show you how traditionally utility scripting is done in other interpreted languages such as JavaScript or Python. I will create 3 files, one a Python script file, a JavaScript file, and a bash shell script file. I have my Python, JavaScript, and bash shell script file. Now I'll add a simple hello world message in these 3 script files. For JavaScript, I'll add console log. I'll add a hello world message in my Python script. And I will add a hello world to my bash script file. Now with these 3 script files in 3 different scripting languages, let's use their interpreters to execute them. First, I'll use Node interpreter to execute JavaScript file. Then I'll use Python for my Python script. And I'll use bash interpreter for my bash file. Now to convert any of these 3 scripts into executable utility scripts, Unix-based systems have a mechanism of hash bank files. In Unix and Linux-based operating systems, hash bank files contains a hash character and an exclamation mark as the first 2 characters, followed by the path of an interpreter program. The rest of the file contains the script code. Upon executing a shebang file, the program loader invokes the interpreter program, which then executes the rest of the script contained in a shebang file. I am creating a hashbang file and I'll add a simple bash script. The first 2 characters in the first line of this shebang file will be a hash followed by a bang character, and then we provide the program interpreter, which is bash interpreter in this case. /bin/bash is the path. The rest of the file will contain my bash script, which is a simple echo hello world. Save this file. Make it an executable by giving permissions. It is now an executable file. I can execute it. To have a similar Java-based utility script, I have slightly modified my previous example. I am using Java interpreter and I am using the source keyword with release 11. Rest of the file contains my Java code. Upon executing this file, the source keyword here will indicate to the Java launcher that we are using single file source code program launching mode, and it will start interpreting this code. Now let's quickly create a useful Java-based utility to create files. Remember, we have a famous touch command in Linux operating system to create files. We can create a similar Java version. We have a file named touch JEP-330. Let's see its contents. The first line here is #bang characters followed by a Java interpreter program name with release 11 source keyword. We are using Java NIO files utility class for creating files, and we will be accepting the command line arguments for file names. We'll make that file executable. Upon execution, this utility script will create files using command line arguments as file names. We are creating a file name file1.txt. So our utility accepted the command line argument as file name and created a file out of it. And if I copy this Java-based utility script to my executable file location, which is user local bin in this case, then this utility will be available everywhere in my system and I can use it. Let's do this. After copying this file to the executable file locations, I can use this utility from anywhere in my system. If I type touch, I'll be having two options. One is the default touch command, and the second is my Java-based version of this touch utility. Using my Java version of this touch utility command, I can create another file, file2.txt. Now we have seen how to use single file source code program launch mode to write Java-based utility programs. Let's quickly review the two limitations in JEP-330. The first limitation is that for your utility scripts, all of the code must be present in one single source file. This is actually not a limitation because for most of the general utility programming cases, the core Java libraries should be enough to cover the scenarios. The second limitation is that first class in your source file must be an executable Java class containing a main method. So that's all about covering Java-based utility scripting topic. If you are planning to write your own utilities, please share your ideas in the comments. Thanks for watching and happy scripting.